A U.S. leading remediation specialist company accepted the challenge of remediating asphalt-accrued contaminated sites in Ecuador's Amazon basin. They had the difficult task of liquefying and removing hardened, non-pumpable asphalt crude littered with jungle debris and vegetation from abandoned pits. They were then faced with having to remediate pit sludges and soils around wellheads having properties similar to asphaltic materials. Their main asphalt crude liquefying product, an all-natural biodegradable solvent, was recommended for in situ treatment of the hardened crude, and their main bioremediation product, a synergistic blend of highly biodegradable compounds, was recommended for in situ remediation of hydrocarbon-contaminated sludges. Samples of both products were submitted to Ecuador's leading technical university in Quito, Ecuador, for laboratory evaluation by Dr. Louis F. Lemery. Dr. Lemery's test concluded that the asphalt crude liquefying product rapidly dissolved field samples in hardened asphaltic crude, rendering it pumpable within 24 hours and without mechanical agitation. Dr. Lemery also concluded that the bioremediation product diluted with 10 parts water was capable of dramatically reducing TPH levels and asphalt crude contaminated sludge within 24 to 48 hours. Crude contaminated soils around wellheads were sprayed with the bioremediation product to effectively break down and reduce the crude to microscopic particles, providing an immediate food source for indigenous bacteria when tilled into the soil. The asphalt crude liquefying product was sprayed over the surface of the degraded asphalt crude. 24 hours later, workers removed debris from the pit for placement in a containment area and pumped the now liquefied crude from the pit into a skid tank for the screening of smaller debris. The crude was temporarily stored in the skid tank until off-site transportation was arranged. After the crude and excess oily waters were pumped from the pit, soil samples were collected by a grid sampling method for on-site TPH analysis. A track hoe was used to rake in and mix the hydrocarbon-contaminated berm with the oily pit sludge. The reduced debris was placed in the pit for treatment as compost material. The bioremediation product was then sprayed over the contaminated material and mixed to a slurry with the track hoe. Fresh soil should be used from the surrounding area for stabilization material, as well as an additional source of indigenous bacteria. This process produced optimum conditions for natural bioremediation.